Today we're going to talk about design criteria and constraints. After you define your problem and start generating some concepts, you have to consider the design validity. So that's the third step of that design process. So when we're looking at that, there are these different steps and different things we have to look at and try to talk to ourselves about and make sure they work before we create that detailed design solution and make those technical drawings. So we're going to look at these different steps today and talk about each one. And when we are going through and looking at our criteria and constraints with every project we do, we're going to ask ourselves these questions and come up with some kind of criteria constraint that we want to happen over the next hour, the next 3 weeks, the next 2 months to create what we need there. So the example we could go with is designing that pet constraint system for keep a dog safe. What can you come up with? What might work, what might not work? So making sure you're specific and concise with that information, not really broad, but go and specific with it, and make sure your client's involved. So who you're trying to make it for, think on both your side as the builder and the client itself. So we're going to look at these steps again: the performance, product size and shape, the aesthetics, the materials, safety, legal, ergonomics, environment, life cycle, and the maintenance that might be used to make this product itself. So the first thing we're going to look at is performance. When you're trying to make something, maybe it's going to have to perform some type of task, or what is the product going to need to do? So you ask yourself, how will it be powered? Max speed, max height, turning radius if we're looking at a forklift thing there. What are we looking to do this? What type of maxing are we going to do? How do we want to perform? Is there a minimum we want to meet? Is there a max that we have to meet? So think and talk about performance when you're thinking about that final product that's there, and list out what might happen as it goes through. Product size and shape. Its form, its dimensions, its weight. If we're going to go ahead and build a bridge, we don't want to make it too heavy because then it's not going to collapse upon itself. If we're going to go and create a part that fits into an electronic component, we've got to make sure that form and dimension fits in there. So think about the size and shape. We're working inside this classroom, so we can't make anything too big. If we make anything too small, it falls through cracks and we lose it. So think about that end product. What size do we want it to be? The aesthetics, the colors, surface treatment, shape, and materials. Are you trying to make something that's a warning device, so you should have bright colors with it? If you're trying to make something where kids can play with, is it got to be smooth? Should it be rough? Should it be able to pick through? What type of material? Are people going to put in their mouth? Is it something that's supposed to biodegrade over time? What is your idea that's there? So think about the materials and the shapes of that product and what that you have to work with as you're trying to go along. The materials goes along with that. Sometimes materials based on cost. This is the cheapest material. This is what we're going to go through. Sometimes materials are just given to us. This is what we have to work with. This is a constraint. We only have these materials, or we don't have enough money to buy the materials that are there. So think about that. You don't want to build metal pieces for toys, sharp objects or something. You want to think more of plastic. So type of materials you're going to go through and use. Safety and legal issues. So human safety, again, goes back. It ties in with the other ones, but are there laws that you're not allowed to use those type of materials or different things there? So again, we don't know safety and laws, but it's still a question we have to ask ourselves and try to come up with something every time we're going and working on one of these projects itself. Ergonomics is the next thing you want to consider. How is everything going to go? Think of that mouse, how it holds in your hand. What should its shape should be? How are people going to interact with it? The way people interact with an object is based on the ergonomics with it, which is kind of the shape that's going. Is it designed for comfort, efficiency, safety, ease of use? So thinking of different ways that that product's going to be used or organized and the ergonomics behind it to be able to work with. The environment, operating environment. Are you going to build this object in the classroom where it's normal temperature? Is it something where you're going to have to use some heat with, so it's got to be able to withstand some heat because it'll be in a like a warm room? Is it something that maybe will go outside, so therefore it's a rainy environment or temperature or sun? Again, not all things that we're going to think about or do with certain projects here, but it's still something that we need to ask ourselves every time we try to do something. Is there some part of the environment or that will interact with our object that might cause it to not perform as well after a week or a month or a year or so. Look at the global environment. Will affect that. Is it biodegradable? Can we make it and recycle it? There's different things we can think of there. So if we're using a paper type of thing, when we're done with that project, hey, let's think about that environment. Let's go ahead and recycle that. What's the life cycle of it? You are making medical devices. Should those medical devices be reused or not? Is there a way we could try to sterilize them so they could be reused? Or are they a one-time thing? Yeah, then that ties in with cost. So a lot of things, as you answer one, you start thinking about other ones that go through that process. So think about the life of it. Do we need it to just work once and then we're done? Or do we need to do a whole bunch of different trials? Paper bridge project, you're building it once. Great. Fling machine, we've got to fling that a whole bunch of times and collect data. So are we looking at something that's just one-time use or 20-time use? Do we want to get that same thing? So that consistency and going back to that data that we want to focus on this year. Durability and maintenance, how often do we have to fix it? Should we be able to fix it? Does the criteria say there's no modifications when it starts running? It's like in the picture here. It's something that's inside, so it's hard to get to and hard to fix. Or we only have certain materials, again, to go and be able to create this thing. So what tools would we have to go through? If we're going to take this project and bring it over somewhere to present it, what are we going to have to bring with us to present that and be able to make it work and use? So we have to think all the different things that could go wrong and how we can fix it quickly when we need to do so. When we're looking at design constraints, resources, budget, time, energy, materials, manufacturing process, there's other things that could come up with. Making sure everything is measurable. Make sure we're testing, focusing on that data as we're trying to go through. Is there a testable way in this class? If we can't test it in here, is it really something we could go through and do and build? Is it going to be worth our time to try and do? Making sure your values and everything else is organized and understood, not just simple sentences, but go through all of the criteria and constraints and then give a nice thought out explanation of why you think you should do something and what your end goal is as you're trying to create something. So we're going to think about these criteria and constraint as we move along through projects here. It is something that I'm going to look for on your documentation. So when you're looking, you're going back to the original and you're trying to ask yourself these like 10 different things and list them out. Try to get one for each one of them as you're moving forward.